In Chapter 4, Section 1, we start by classifying triangles. And the first thing we're going to do is classify these triangles by angle measure. An acute triangle has 3 acute angles. And I'm going to draw something like that. All 3 of those, in this case, they're all different sizes, but they are all 3 acute angles. Equiangular triangle might be a new term for you. Equiangular triangles have 3 congruent angles. So those 3 angles are all the same. A right triangle has 1 right angle, and an obtuse triangle has 1 obtuse angle. And you will notice for a triangle to be acute, you need 3 acute angles, and for a triangle to be right or obtuse, you only need 1. So the first example, we are asked to classify each triangle by its angle measures. First of all, triangle BDC, from B to D to C. It's kind of hard to see, but that B is actually the 100 degrees, which makes that obtuse, and that makes that an obtuse triangle. Triangle ABD, angle A is 80 degrees, and that other part of angle B is also 80 degrees, because these two have to add together to get 180. So 80, 80, 20, that is 3 acute angles. So that is an acute triangle. Letter C, triangle FHG. If this is a right angle, and this is 30 degrees, 90 minus 30 is 60. And that makes angle F, angle H, and angle G all 60 degrees. And that makes this equiangular, or an equiangular triangle. All 3 of the angles are equal. And lastly, letter D, triangle EHG. You have a right angle right there, so that makes that a right triangle. Our first theorem is the triangle sum theorem, and we have 3 angles in a triangle, and angle 1 plus angle 2 plus angle 3 equals 180 degrees, or the 3 angles in a triangle equal 180. And down here we need to find some angle measures. Angle XYZ. Well, if we use triangle XYZ, we can do 180 minus 62 minus 40, the whole triangle, and we subtracted those 2, and that makes this angle right here 78 degrees. Angle YWZ, this time I'm going to use the big triangle. 78 plus 12 is 90, so that makes that a right angle. And if we do 180, this whole triangle here is 180 minus 90 minus 40, that makes this angle right here 50 degrees. The next one angle MKN. We have 3 angles in a triangle, so we can do 180 minus, I think that's 88 and 48, which makes this angle 44 degrees. Well, if that angle is 44 degrees, these two things are equal, and that is also 44 degrees. And we are trying to find angle MJK, which is right there. And we can do 180 minus 104 minus 44, and that angle right there is 32 degrees. At the top of the next page, we have a definition of a corollary. And a corollary is a mini-theorem, can be proven very easily from a theorem. And our first corollary talks about the other two angles in a right triangle. So we have a right triangle, and there's going to be something about these two angles. Well, if this one is 90 degrees, 180 minus 90 is 90. So those two angles, angle 1 plus angle 2, equals 90 degrees. And the second corollary is about an equiangular triangle. If all of those angles are equiangular, 180 divided by 3 is 60 degrees. So there we would say all angles are 60 degrees. So this first or next example, the measure of one of the acute angles in a right triangle is given. What is the measure of the other acute angle? Well, together they have to add up to 90. So 90 minus 63.7 is 26.3. The next one would just be 90 minus 2x. For letter C, I'm going to do 2 divided by 5, which is 0.4. And then I will do 90 minus 48.4, and that would be 41.6. And the last one, if one angle is x degrees, the other one will be 90 minus x. Now we have some vocabulary. This is the interior of the triangle, anything on the inside. All of this out here is the exterior of a triangle. These are the interior angles, angle 1, angle 2, and angle 3, because those are all inside. And angle 4 is an exterior angle. Now, remote interior angle, if I were to send you to a remote location, that would mean far, far away. So if this is the exterior angle, the remote interior or the far away interior are these two right here. So if we're talking about this angle, the farthest away, this one's right next to it. So these two are the remote or far away interior angles. And we have a theorem about this. We're going to put angle 1 right there, angle 2 right there, and then 3 is going to be, angle 3 is going to be an exterior angle. So angle 1 plus angle 2 equals angle 3. Or, in English words, you can say the exterior angle is the sum, means we're adding them together, of the remote interior. And I'm going to move that up. I hope you can see it. So these two angles, when you add them together, you get this outside one. The exterior angle equals the sum of the remote interior angles. Looking at our next examples then. These two angles added together, sum of the interior, remote interior equals the exterior. So we will have 15 plus 2x plus 3 equals 5x minus 60. So 18 plus 2x equals 5x minus 60. Adding 60 to both sides. Why did I add 60 to both sides? I guess it doesn't matter. Becomes 78 plus 2x equals 5x. And subtracting 2x from both sides, you have 78 equals 3x. Dividing both sides by 3, x equals 26. Now, just like with all of geometry, we're not done. We were asked to find angle B. So 2 times 26 is 52, plus 3 is 55 degrees. So angle B equals 55 degrees. Example B, this exterior angle, so 6z minus 9 equals the sum of the remote interior equals 90 plus 2z plus 1. So that becomes 6z minus 9 equals 91 plus 2z. From there, you subtract 2z from both sides. And you should start with the variables. I don't know why I didn't do that on the first one. 4z minus 9 equals 91. And adding 9 to both sides, 4z equals 100. Dividing both sides by 4, z equals 25. Remember, we're not done yet. ACD is this outside angle. So 6 times 25 is 150. Minus 9 is 141. So angle ACD equals 141. Example C, this exterior angle, 124, equals the sum of the remote interior. So 124 equals 18x minus 2. 10x plus 8x is 18x. Negative 5 plus 3 is negative 2. Adding 2 to both sides, 126 equals 18x. (126) divided by 18 is 7. And in this case, we were asked to find angle B. So 8 times 7 is 56, plus 3 is 59. Letter D, exterior angle, so 9x plus 2 equals the sum of the remote interior, so 23 plus 5x minus 1. That becomes 9x plus 2 equals 22 plus 5x. From there, you subtract 5x from both sides, and you have 4x plus 2 equals 22. And when you subtract 2 from both sides, 4x equals 20. And then x equals 5. And you are asked to find angle PRS, which is right here. So 9 times 5 is 45, plus 2 is 47. And letter E, exterior angle, 68, equals the sum of the remote interior, 3x plus 4x plus 5. So that becomes 68 equals 7x plus 5. Subtracting 5 from both sides, you have 63 equals 7x. And when you divide both sides by 7, x equals 9. And in this one, we are asked to find angle D. 4 times 9 is 36, plus 5 is 41. Our next theorem is the third angles theorem, and we're going to draw two congruent triangles right here. And I'm going to tell you that angle 1 is congruent to angle 2. And here's a 3 and a 4. So angle 3 is congruent to angle 4. And the third angles theorem says if two angles in one triangle are congruent to two angles in another triangle, then our third angles are congruent. So 1 was congruent to 2, 3 was congruent to 4. So these two angles were congruent to these two angles. So we can say the third angles are congruent. And we're going to use this on the examples on the next page. These two angles are equal. These two angles are equal. So the third angles are equal. 4y squared equals 6y squared minus 40. From there, we will subtract 6y squared from both sides. And that becomes negative 2y squared equals negative 40. And then dividing both sides by negative 2, you have y squared equals 20. And you don't have to square root this. You can just take this and put it right in the y squared. 4 times y squared, which is 4 times 20, is 80. And if you do 6 times 20, that is 120 minus 40, which is also 80. In example B, two angles in one triangle, congruent to two angles in another triangle. That means your third angles are congruent. So 2x squared equals 4x squared minus 32. Subtracting 4x squared from both sides, you have negative 2x squared equals negative 32. And when you divide both sides by negative 2, x squared equals 16. You can square root it, you don't have to. 2 times x squared is 16, is 32. 4 times 16 is 64. Minus 32 is also 32. Example C, we should be given that these angles are congruent. Two angles in a triangle congruent to two angles in a triangle. So we have 10x minus 3 equals 8x plus 12. Solving that, you subtract 8x from both sides, and you have 2x minus 3 equals 12. And when you add 3 to both sides, you have 2x equals 15, and x equals 7.5. 10 times 7.5 is 75, minus 3 is 72, and 8 times 7.5, I believe, is 60, plus 12 is also 72. And example D, these two angles are equal to these two angles, so the third angles will also be equal. So 3x squared equals x squared plus 50. Subtracting x squared from both sides, you have 2x squared equals 50. Dividing both sides by 2, x squared equals 25, and x equals 5. You don't have to square root it if you don't want to. I'm actually going to use the x squared. 3 times 25 is 75, and 25 plus 50 is also 75.